Hi all, from today we will see a subject called data structures in computer science. First we will see the definition of data structures and later we will see why do we need to study data structures at a first place. So when it comes to the definition of data structures are the methods of organizing, storing and managing data in memory so that data can be accessed, modified and processed efficiently. Before we dive into data structures definition, let us say we have to find a meaning of one vocabulary word in a dictionary. Suppose in the dictionary we have a 10 lakh words and those 10 lakh words are not properly arranged in a alphabetical order. Let us say we don't have any organization of data. That means those words are not arranged in alphabetical order. Let us say, for example, if we want to find a vocabulary word, suppose we don't know the meaning of particular vocabulary word. Let us say we want to find a meaning of notorious word. So that we have to scroll all the pages of dictionary until you find the word called notorious. Because there is no organization of data in dictionary in our particular case, we will end up wasting lot of time to find that particular word in dictionary, right? So if we organize the data in dictionary in alphabetical wise, it will be very easy to find that particular word in dictionary, right? So data structures provides a ways of organizing data. So this is the one type of organization. So due to this type of organization and storing and managing, we can access and modify and process efficiently. So in programming, in general, any programming language, for example, not only in C programming, any programming language that you take, like Java, Python, JavaScript, any programming language, data structures define how data is stored in memory, how data elements are related to one and each other, and what operations can be performed on that particular data, like searching the data or inserting some data or deleting and updating. So there are other operations as well. These are some examples of operations. So let us see the definition very deeply from the next slide onwards. When it comes to organization of data, when it comes to the definition of organization, we have to arrange the data elements in a specific order. Any order, it doesn't matter, but that order is your requirement. For example, if we have the lot of students in class, we will arrange them in like we say roll number wise, or we can arrange them in girls and boys, that is also one organization, and we can arrange them in day scholars and hostel students. So there are n number of ways to organizing the data. That completely depends on your programming requirement. So there is no particular way. So the better organization provides you better accessibility of data. That's what I mean to say. Why organization is needed? If the data is not organized, searching becomes very slow, and inserting and deleting a particular element is also becomes difficult. So the key point here is, so organization means deciding how data elements are arranged and how they are interlinked. That is the meaning of organization of data here. And when it comes to the example, suppose we have a library with 10,000 books. Without organizing the books placed randomly, without organization, let us say the books placed randomly, to find one book called, let us see by Dennis Ritchie. Let us see by Yashwant Kanetkar. I am sorry. Let us see by Yashwant Kanetkar. You need to search every shelf in the library until you find that particular book. suppose we don't have any organization of books. I mean, the books are placed randomly over all the shelves. So in this case, the time will be wasted, right? So suppose we have a organization of books in that particular library. Let us say books are arranged by subject, author, book ID. You know where to exactly look and where to exactly find that particular book. This is called organization of data. Let's look at what is the meaning of storing in data structure. Storing means allocating memory locations to hold data values, deciding where and how the data will reside in memory. So storing means allocating memory locations to hold the data. Simply means what are the key aspects of storage? That depends on the data structure. There are some storage aspects. One is continuous storage, that is contiguous storage. Arrays follows continuous memory locations, and there is another type of storage allocation strategy called non-contiguous storage. The elements are scattered in memory, but they are interlinked with a concept called linked list. We will see what is a linked list in further upcoming sessions. So, and one more key aspect of storage means static or dynamic memory allocation. What is static means the data is fixed and you need the memory allocation is fixed. You need there is no way we can decrease and increase the memory locations. That is called static. Arrays follow static memory allocation. When it comes to dynamic memory allocation, you can increase the memory slots or you can decrease the memory slots whenever you need. So linked list follows dynamic memory allocation. So storing means deciding the memory layout and allocation strategy. When it comes to the example of storing of data in library, storing means placing the organized books into physical shelves. In the library, shelves represent memory locations. Each book is placed on a specific shelf position. Books of same subject will be kept together. To connect with programming, shelves are nothing but memory blocks. Book is data and shelf number means memory address. The key point here is storing means allocating memory and placing data into it. That is the meaning of storing in data structures. And when it comes to the management of data, management means controlling how data is created and how data is used and how data is destroyed during the program execution. When you want to create a particular element in program, you need to allocate some memory, right? That is called memory allocation. In C, we will use malloc as part of dynamic memory allocation. We'll see what is dynamic memory allocation in upcoming video lectures. When you don't want that particular memory, you can free it. Free in the sense delete the memory. That is called memory deallocation. Sometimes if you don't free the memory, there will be memory leaks. You need to prevent those memory leaks. So these are all part of management of data. So data structure provides a way of management of data. So you can resize the data structures if you want. So these are some examples of management of data. When it comes to examples in terms of library, managing means handling the life cycle of books in the library. For example, in the library, if a new book arrives, you will assign subject, author, self. That means you will place the particular book in a separate allocation. I mean to say a separate self location. That means this is nothing but memory allocation. For example, you need to update if you want to move that particular book to another self. That means update location. Suppose a book is moved to one location to another location. When it comes to library, one self to another self. That means update location. So this is also a management of data only. Suppose if you want to remove some books because they are outdated, because they are no more valid in this particular scenario, you can delete those books. So you can remove those books. We will have some empty free shelf space. Suppose one book is damaged, you need to modify with another new book. That is called modification. These are examples of management of data. So what is the key point here? Managing means controlling the data, like addition of data, usage of data, updating and removal of data. These are all part of management of data. So data structures provides some ways of organizing the data, storing the data and management of data. I suppose you get the meaning of what is organization, storing and management. And let us see, if we follow these things, the data can be accessed, modified and processed efficiently. So if the data is organized, we should be able to find data quickly, and we can easily modify the data, and we can easily perform some operations using minimum time and memory. So that is the beauty of data structures. Suppose you want to access a particular book, because books are organized by subject, you can store it in noun selves. You can directly go to that particular subject or author, book ID and then self. There is no need of random searching because the data is organized and the books are organized in particular way, so that you can directly go to particular shelf and you can take that book if the data is organized. What you can observe here, if the data is organized, you can find the data quickly. That means in the minimum time you can find the data quickly. That is the meaning of accessed here. When it comes to modification in the library, if you want to change the book or the name in a record, or replace an edition or update book ID, since the records are structured, only specific entries are changed. No need to rearrange all the books. So next is the processing. If the data is organized, the processing becomes very efficient. Like counting number of computer science books, you can do it very quickly, and finding all books by an author. For example, there are some books by Yashwant Kanetkar. Let us see one book, and let us see sharp one book, and one more book called Pointers, I guess, Dive into Pointers or something. So he wrote three or four books in C programming language. We can find all books by particular author. That's what processing means here. Listing books in ascending book ID, you can do that. So processing is very fast when the organization of data is correctly done. Now let us see why we have to study data structures. Studying data structures is very important because every program works on data only. If we organize the data very well, then it will directly impact the performance and scalability of software. So if the data is organized very well, then we can perform some operations. We can perform number of operations very quickly since the data is organized correctly. So initially, so let us say the program, let us say the software is intended for 10 users. We can scale up to 10,000 users or 1 lakh users. If we use correct data structures and correct organization of data, we can scale up the software. When it comes to real world examples, we have numerous applications of some data structures. We just listed some real time examples over here. There is some data structure called stack. Stack is used in browser history. A stack is used in undo and redo operations. For example, you can do undo and redo operations in text editor, right? Like Control Z and Control Y. So inside these Control Z and Control Y, and I mean to say undo and redo operations are entirely developed in stack data structure only. These are few examples and few real-time examples of stack. And when it comes to the queue data structure, the call center organizations will maintain some queues. So based on the tickets, they will attend those calls. For example, 10 calls are received at the end of call center guy. They will take the first come first serve basis. That is the meaning of queue here. In general, if we want to go to movie, we will take the movie ticket, right? In that place also we use queue data structure only. Queue follows first in first out principle. Whoever comes first, they will get the ticket and they will leave. That is called first in first out. So queue, and in operating systems as well, there will be priority of tasks. There are so many tasks are running parallelly, right? So OS decides on which task to be performed based on queue data structure only. When it comes to linked list data structure, your music playlists are also part of. I mean to say, music playlists are completely uses linked list as a data structures in the programming part. When it comes to file systems, that means your C drive and D drive. In D drive, we have so many folders. In folders, we have so many different files. This entire path is like a tree in internal programming. So every file system uses tree data structure. When it comes to maps and GPS, shortest path routing. For example, if we want to go to one place to another place, there will be n number of ways to go to one place to another place. Let us say like that. Let us assume like that. So with the help of graph data structure, we can do, with the help of some algorithms like shortest path algorithms, we can find shortest path very easily. So these are some good examples of data structures in real world. So data structures convert real world problems into code. That's what I mean to say here. And if we study data structure well, this is the foundation for advanced computer science. Without mastering data structures, you cannot understand operating systems, databases, computer networks, machine learning, and artificial intelligence. Without strong data structure knowledge, you won't be appreciate the algorithms of OS and databases. It is difficult to understand. So data structures are the backbone of computer science. So that is the reason we have to study data structures. So that's it for this video. We'll see the classification of data structures in next video. Thank you so much for watching.